This is a video on section 5.5, the last problem, number 13, which is an exponential growth decay problem. In fact, it's decay. All right, so let's get to that. Just let me scroll. All right, 13. Let me blow this up a little bit. Okay, so the half-life of deuterium-149 is 3 days. Okay, so we know we're talking about a half-life problem. And on day 10 at 8 a.m., a sample has 256 grams. State how much there is at the following times. Only use a calculator where it's specified. Okay, so day 13. So let's see, we know, so I'm going to write down what we know. We know, day 10 is our reference, and we know on day 10 there's 256 grams. And then let's also highlight the fact that we know the half-life is 3 days. Okay, perfect. All right, so let's get to part A. On day 13, so day 13, and so the difference between day 10 and day 13 is 3 days, which we know is the half-life. So it'll be half of what it was on day 10 on day 13. So I didn't want to put, why did I write A? We're going to say A13 to indicate the amount on day 13 will be half of that amount on day 10, to 256 divided by 2, which is 128 grams. Okay, that's part A. Part B. Now looking at the next part, part B, day 22. Again, notice all the times are the same, just to be an exact amount of days later. All right, so day 22. Let's figure out how many, is if there's a difference between 22 and 10, or we can do 22 and, actually, let's look at 22 and 13. So between 22 and 13, so 22 minus 13 is 9 days. And remember, 3 days is the half-life. So if I take the 128 that we just did, so 128, and then how many half-lives are there since then? Well, if there were 9 days, that means there's 3 half-lives, so 1/2 to the third. And that will give us, so it's 128 divided by 8, or 16 grams. Part C, if we want A25, so notice that is 3 days after what we just found, which was day 22. So A25 will be 16 divided by 2, just half of that, because it's one half-life period, or 3 days. So that'll be 8 grams. Part D, this is where we're going to use a calculator. So day 17, and I think in my solutions, I use day 10 as my reference. You could do day 13, but I'll be consistent with my solution. So if we're starting off with a reference of, so we're finding, this is part D. We're going to use our calculator, by the way. So A17, we're using 256 as our starting point. So we're going to, so a half is the base, and I want to figure out what's the difference between day 10 and day 17. So I'm going to do 17 minus 10. And then, remember, I want to then divide that by the half-life, which is 3 days. So I'm really putting in my calculator 256 and then raising 1/2 to the 7/3. And when I do that, I get about 50.8 grams. Oops, I had to do 0.8 grams. Oh, that looks horrible. Let me erase that. 50.8. Okay, now, so now always be on the lookout for when I tell you to use a calculator, then probably some problems after that are going to rely on that calculator found answer. So part E is saying how much from amount at day 20. Well, notice I just found day 17, and the difference between those is 3 days. So I'm just going to, which is the half-life. So I'm just going to do 50.8 and divide it by 2. because it's one half-life period since then, so 25.4 grams. All right, let's see what F brings. F is day 7. Okay, so day 7 here is, so A7. Let's see if we can relate that cleanly to something we know. So day 7 is, I noticed, 3 days before day 10, which was my initial amount I was given. So if we're going back in time, to go from day 7 to day 10 would have been half of what it was, because that is the half-life. But if I'm going backwards, I'm actually going to be multiplying by 2. So A7 is going to be 256, what it was at day 10, times 2. Remember, earlier in time, we're bigger, because over time, we're getting smaller. So this would be 512 grams. Okay, part G, day 4. All right, this is related to day 7. So how is it related? It's 3 days prior. So I'm going to take my 512. 3 days, again, remember, is the half-life time. So because I'm going back in time, I'm multiplying by 2. So 1,024 grams. H, day 0. Okay, now we're using a calculator. So day 0, let's go back, since we did for part D, we used 256. We can do, again, day 10 as our reference. So 256. And again, because I'm going back in time, I'm going to be multiplying by 2. So let's see how many times I have to multiply by 2. The difference between day 10 and day 0. So I'm going to do 10 minus 0 over 3. Because, again, the half-life was 3. So I could do that. Or if you didn't quite want to work with 2, instead wanted to work with a half, you could still do a half, but then you would do the current time minus my reference over 3. So you'd be doing 1/2 to the negative 10/3, which, by the way, is the same thing as 2 to the 10/3, because 1/2 to the negative is the same thing as 2. So either way would work. Your answer here, again, this was a calculator one, is 2580 grams. All right, so let's go last 2. Day 5. So day 5, and there's actually a few you could use here. If I think of day 5, I could relate it to A17. Let's see why. So day 5, A5, again, we're not using a calculator for this one. I would do 17 is 15.8, and I'm going back in time, so I'm going to put in 2. And let's do the difference between 17 and 5. So 17 minus 5 is 12, and 12 divided by 3 is 4. So that is what makes this nice. It's because it's going to be 2 to the 4th here. So you would do, in other words, you're doing 50.8 times 16. Granted, I mean, it would be nice to use a calculator for that, but you could do it without. So 812.8 grams. All right, last one, J, is day 2. And day 2 is just 3 days prior to to the amount on 5. So A2, I'll just take what I just got on day 5 and multiply it by 2. Again, going back in time, and 3 days is the half-life, so I'm going to multiply by 2, and that's going to be about 1625.6 grams. All right, so there's a lot in that problem, a lot to think about with half-life, whether you're going forward in time or backwards in time.